We'll finish 9.4 with this example, and then we will do some retries, and then that will conclude. This one can be a little challenging, so let's take our time here. So Julie bought donuts for a party. 1/6 were jelly, 1/3 were cinnamon, and 5/6 of the remainder were glazed. Julie bought 20 glazed donuts. How many did she buy in all? All right, so we're going to look at this here. So 1/6, so this whole strip represents all the donuts. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So this 6th here is jelly. So 1/6 is jelly. All right, so let's shade that in. And then 1/3 were cinnamon. So we're looking at jelly here. I'm sorry, 1/6 here. So I'm just going to copy all this, bring this down. And now if we look at this as thirds, right, that would be 1/3. That would be 1/3. And that would be 1/3. So let's put her cinnamon over here. So her cinnamon is 1/3. And now 5/6 of the remainder are glazed. So we've got one more section here. Let's see if I can get all of it. So let's make this red. So 5/6 of this. Well, unfortunately, we have to redo our break here because we need to turn this into 6 pieces so then we can shade 5 of them. Well, we only have 3 pieces right now. But if we were to cut these 3 pieces in half, we would get 6. And so let's do that everywhere. So we're going to cut these 3 pieces in half. And so we just cut all of our pieces already in half. So now 5/6 of these, 1, 2, 3, 4, 5, are glazed. And then they say that these glazed, she bought 20 of these. So now, how many did she buy in all? So let's see what we've got. We've got 1, 2, 3, 4, 5 parts. And our tape diagram is in all the same parts. We split everything up so it's the same. 5 parts, there are 20. So 1 part, if we look at that, would be 4. So how many total parts are there in this diagram? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 parts. So if each part is 4, that would be 48 total parts. So that would be 48 donuts. So Julie bought 48 donuts. Well, let's see if we can use algebra to solve this. Rather than, sorry about that noise, the strip diagram. So if we look here, let's let X equal the total number of donuts, right? So let's take it piece by piece. We know 1/6 of, that's multiply of the donuts are jelly. We know 1/3 of the donuts are cinnamon. And we know 5/6 of the remainder. Okay, so remember, let's think about this for a second. 5/6 of the remainder. Well, that would be the total, 5/6 of the total minus the jelly and minus the cinnamon. So let's use expressions for that. 5/6 of the total, that's X, minus the jelly minus the cinnamon. And we know that this amount, 5/6 of the rest, those are the glazed, we know that that's 20. So we could solve this equation, and I've run out of space here, so let me see if I can make this one a little smaller or move this one over. Let's see. Let's just move this guy. Oh, it's not going to let me. All right. We'll just move him over here. So we've got 5/6, and let's combine this. So we know that this is 1. So what I'm basically saying here is what is 1 minus 1/6 minus 1/3, because that's our X. Let's make all these denominators 6. So 1 is the same as 6 over 6 minus 1 over 6. That's 2 over 6. So 6 minus 1 is 5. 5 minus 2 is 3. So we get 3 over 6. Well, we know that that's just 1/2. So 5/6 of 1/2 X is equal to 20. Just kind of continuing this here. And so we can multiply this. So we get 5 times 1 is 5. 6 times 2 is 12. X equals 20. And there are a couple different ways you can solve this, but we can multiply by 12 over 1 to cross those out. Remember, 12 over 12 is 1, so we get 5x equals 240. We'll divide both sides by 5. We get x equals 48 donuts. So you can solve this with a strip diagram, or you can solve this with algebra. And here it is, to help you out a little bit more, just another expression of it, a different way to do it with cleaner lines. So now you go ahead and try these. Now, these are super challenging, y'all. Take your time, take your breaks. Try not to just jump to the end. You might want to print out some graph paper here so you can see your, like a grid paper, not graphs, but like, so you can actually make sure that your parts are equal. So when you divide it, that might help also. And then press play when you're ready to see the solution. That's the first one. And there's the second one. So just a couple notes about strip diagrams. They're really powerful. They really help students reason. You want to start with these when you're dealing with students. You want students to make sense of them. It's less important that they move towards the algebra until later. Having a strong sense of understanding algebra is huge. But it is really important to know that they don't substitute it. You don't want to send students into later grades without being able to use algebraic equations with variables, especially in high school and beyond. So this is a foundation. You don't want to move away from them too quickly, but this is a great tool to use. And then taking a moment here to read about some research that supports the fact that these are really great in problem solving. And then that concludes section 9.4.